Hi everyone! So today we're going to be talking to you guys about how our team implements CREO and how it can be really, really useful.
Our team uses CREO Parametric as our chosen 3D design CAD software. We've been using it for about 6 years, and we find it to be the best software because of the different capabilities that it has and because it is such a powerful program. What top-down versus bottom-up designing is top-down designing means that you are creating your constraints of your robot in your design, and then you are forming everything around those constraints. So you can create your 18-inch sizing box using datum planes, and then you create your other parts in reference to those planes and axes. That way everything just kind of like fits in there instead of bottom up, where you start with like your base perhaps and then you build everything up on top of that. When we're designing in CREO, we like to go with a top-down assembly technique. This is something that's used in the industry because it allows for your part to be more flexible as it continues to change. It means that if one part of the robot that you're designing has to be changed, or if it goes wrong, if maybe a hole freaks out, then your entire CAD doesn't have problems. And it's also really beneficial if you want to stay within the 18-inch box and more specifically pushed a little bit. Our team used to use bottom-up designing back when we started, and when we were doing this, we would often create the main structure for our robot's base, and then from there we would add on to it. So we would add on the wheels, the attachments, all the different parts based off of that. We would constrain the different parts to the corners of that base, which meant that when we were designing it, the base itself needed to be what was inside 18 inches, because if you constrain something to the base and the base is outside 18 inches, it would have a problem, so it wasn't very flexible. Then we ended up moving to top-down manufacturing because our designs got more complex. There was one year where we ended up adding a part that has these angles on it. In order to get the angles to fit within 18 inches and get the proper radius for everything, we had to create our sizing box virtually in CREO using datum planes and then constrain the different attachments to the sides of that box. That way each assembly part had about 6 or 7 different constraints built into it, and that's what you're constraining things to. So instead of doing surface to surface, you're constraining like an edge or a surface to a plane or an axis. An example of this, to try to make it more clear, is if you're creating a ramp that's in an angle, you can constrain the bottom edge of the ramp to a datum plane that's the bottom of your robot. Then you can constrain the top front edge of your ramp to the frontmost part of your plane, so you can figure out how the distance you want it to be. Then from there you can instead of doing like a flat surface, you can do the bottom of the ramp once again to that bottom datum plane of the robot, but then you can use that as an angle offset, so you can adjust the angle. So that's going to take care of your distance back and forth, your height up and down, and your angle. And then you can, from there, just use a centered datum plane in order to constrain it to a centered datum plane instead of the robot if you want your ramp to be perfectly centered in the robot. And then that will hold it in place, and it will keep everything within that 18-inch boundary box. So another reason why doing top-down design is really beneficial is because it allows you to create a really custom robot. Because if you can design your robot completely prior to building it, then you can create fully custom parts and you won't have to worry about having different things run into each other or having to drill unexpected holes.
Yes.
Really beneficial thing that our team uses in conjunction with this is the activation feature in CREO. So when we create a part, we'll create the basic shape of it, we'll put it into the design, and then from there, inside of the assembly itself, we then activate the part. What this does is it will gray out the entire rest of the robot except for the one part that you're working on. and it allows you to continue editing that part, putting holes in it, making cuts, extrudes, whatever. You're also allowed to see the rest of the robot along with it. So if there's a particular hole of another part that you need to reference, then you can do that within the part. So it's very similar to like if you were drilling a part in real life. You would line two things up together, where you need a hole, you mark it, then you drill it. You can do that in CREO where you find, since you're activating the assembly, you can find that hole, you can reference it in the design, and then you can put a hole in it. And this is also really, really beneficial because if you end up moving your particular parts around, if you use references, then they will move with it. So if I have one hole that's in a part and I move that part maybe an inch to the left, my hole will move with it because it will just follow that reference. That can end up looking extremely overwhelming if your main assembly is just part after 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 part. Instead, use lots of sub-assemblies anytime that you can. If you have a particular attachment, make it a separate assembly. If you have a particular part that has to like go together, like a servo block mount, make that a separate assembly because it makes it way easier to find things if they do break in your CAD, so then your model tree won't just be like overwhelming with like Tetris part 1, 6, 4, 9, 8, 2, 3, and like all these failures, so it'll be way easier to track things, fix them. If you do need to change something out, then that's also a lot simpler because our team, we find that every time we rebuild the robot, we'll change out the attachments, and if they're all separate ones, then we'll have failed parts that go along with it if you delete one of those parts. But if you have it as a full assembly, then you can just like delete the assembly and it's not going to have problems. So, story time.